Okay, in the last video we worked on A and B and we determined that the pumpkin is going to be in the air 3.48 seconds and the pumpkin will travel about 244 horizontal feet. So the next part of the question is, when is the pumpkin going to reach its maximum height and what will that height be? Now we can do all of this in the calculator. So we have our equation in y equals, and what we need to do is take a look at the table. And in the table, look, I'm still counting by hundredths here from the last example, so we'll go back and fix the table, start it at 0 and then count by 1. And if I want to look at the graph, I'm going to recognize that somewhere in between 0 and 3 seconds, that is when my pumpkin is going to be above the ground. So I want to make, since x represents my time, I want to set my x's up to be able to see all of that time the pumpkin is going to be above the ground. So I'm going to start with a minimum of -1 in order to see my y-axis and the starting point of my function. I'm going to go all the way up to 4 because if I look at my table, 4 is the first place where I have a negative value. So I'll be able to see all of the positive values here. And then my positive y value, so this is the height that the pumpkin is going to reach, the vertical distance, so the height above the ground. And my maximum is right somewhere, hopefully it's like in here somewhere around 60 feet. So my window, I want to set my y's up. I don't want to be -10, so I'll do -1 again, and that's going to allow me to see the x-axis. And then I'll make my y max something like 65. So I definitely can see the top of the parabola. And remember, the parabola is the shape that a quadratic function takes. So now I'm going to count by 5s just so that my y-axis looks kind of nice. When I push graph, I'm going to be able to see the whole trajectory of the flight of the pumpkin. And then somewhere right up here is when I am going to get the maximum height. So we can do second calc. Okay, calculate is right up here, and I'm looking for the maximum, which is number 4. And the first question is the left bound, and I have my little blinking spider right here. So I want to be a little bit to the left of the maximum, and that's asking for my left bound, yes. And then I want to be to the right of the maximum. So I click over, make sure I'm on the other side of the parabola, hit enter, and then it says guess. So the calculator is going to guess the maximum, and the maximum is 59.0625 feet, and that occurs at about 1.56 seconds. Okay, so when will the pumpkin reach its maximum height? That answer was 1.56 seconds. What will the height be, which I already forget, so we'll come back and check it out, 59.0625. Okay, and then the next question is, what is the horizontal distance going to be when it reaches its maximum height? So just like the last question, when it asked for how far does the pumpkin travel, okay, we have to plug it in for D. And remember, D was equal to 70 times T. So we have to substitute in the 1.56 into this equation. So we do second quit, 70 times 1.56. And we get that the pumpkin is about 109.2 feet from the pumpkin chucker. and that takes care of the example. However, I want to show one more thing in the graph here. Just like how we could find a maximum, you may have noticed that there is another option here, 0. You can also use the calculate function to find the 0. So I'm all the way up at the top now. One of the zeros is over here in the negative, so that doesn't really matter. But here's the other 0 right here. So if I scroll all the way over, just keep my finger on the arrow, okay? If I select here, that's going to be my left bound. So I push enter. Now I want my arrow, I need it to be over here somewhere. So I need my y actually to be negative. So I'm just going to keep clicking until I get my y to be negative, this y right here. So it's almost negative. Probably one more click will do the trick. There we go. Now I'm in negative. I can't see my little thing anymore, but somewhere in between those two, I'll get the 0, and there it is. Y is equal to 0 at 3.48 seconds.